Saxon's Calculus Lesson 76 is about functions of y. We jump right into example 1. Find the area of the region completely enclosed by the y-axis, obviously that one, and the graph of x equals 1 minus y squared. So we have not solved this for the y equals. I have two options. I can go ahead and solve it for the y and then pick values for x and plug in, or I can just kind of work it backwards and choose my values for the y, 0, 1, -1 perhaps, and work my way backwards to the x. So if I do that, 0 squared is 0, 1 minus 0 is 1. 1 squared is 1, 1 minus 1 is 0. -1 squared is 1, 1 minus 1 is again 0. So I know, well, hang on. Yeah, okay, 0 is giving me two different answers. And that's okay because this is a parabola because this is squared. So 0 is going to give me a 1 and a -1. Then 1 over is giving me nothing up or down. And since I know it's a parabola, the 0 is, these are mirror image points. So this is definitely my vertex point. So it's going to go graphing the parabola like this. So we are finding the area of the region enclosed by the y-axis. So basically this section is what we're looking for. So we know that to find the area, we need to integrate. And this is where I did need to change the problem, okay, because my x values that I'm using to bound are from 0 to 1. Just a second. Or if I integrate this equation, the y values are acting as what I'm choosing, so that boundary is between -1 and 1. I am going to do that. I'm going to leave their equation and then bound it from -1 to 1 with the 1 minus y squared. And we could have changed it and gone the other way, and then I would have used the boundary of 0 to 1. But since I'm going to use the formula this way, it should work out just fine. So now when we integrate this, we get y minus 1/3 y cubed, and then we're plugging in the -1 to 1. Just double checking, no errors so far. Okay, so now let's plug in our 1. So we have 1 minus 1/3 is the highest, minusing the lower answer, which would be -1 minus, at the moment, dropping it down, that's -1. So turning that into positive 1/3. So then if I make a common denominator, 3/3 minus 1/3 is 2/3 minus okay, so -3/3 plus, so that's -2/3, changing that to positive 2/3. So 4/3 is the answer, units, because it didn't give me anything, squared, because it said find the area in that boundary. Example 2. Find the area of the region completely bounded by the graphs of x equals 3 minus y squared. Now that's going to be something super similar there. And y equals x minus 1. So we're going to graph, and if I do the line, it doesn't matter which one I do first, but if I plug in 0, I would get -1. If I plug in 1, I would get 0. If I plugged in 2, I would get 1. So I have my straight line here. Hopefully that's long enough to bound with the other one. Then again, if I plug in 0, I would get 3 minus 0, so 3. So that would be 3, nothing. Then 1 plugged in would be 3 minus 1, 2. So that would be 2, 1, that's this dot. And then if I plug in negative 1, 3 minus the 1 is again 2, and that was 2 gave me the negative 1. That's here. So this would be the vertex point, and because these are mirror imaged, so my parabola is here. The other, oh, you know what? I need to extend that because I want them to cross, so not an arrow here. So now it's crossing in 2 places. And extend that just a smidge more. Okay. What was I saying? Oh, the other way I would have known this parabola went here is because this shifted it 3 units from 0, 0. So that's another clue that that's where that goes to. So now I know we need to integrate because we're talking about finding the area. This one is in X and this one is in Y. And I need them to be the same. So this is the easier one to solve for the X. So let's do that. Let's make this X equals, so it didn't move, the 1 moved, Y plus 1. So I want to use this one and this one having solved for the X's. Okay, so the one that is higher is the line, which will now be the Y plus 1. And we know we're minusing the lower area from that, which would be the 3 minus y squared. And my boundary, since I solved for the X, would be here on the x-axis. That's 1. Wait, no, that's the, hang on. Am I flipping that in my head? Shouldn't be. Sometimes the flipping of these can be confusing, and I fell into that trap. So because I am looking at solving for the X's, I'm not looking at this as line then parabola. I should be looking at it this way. So the parabola is above the line based on solving for the X, which means these two should have been flip-flopped. So when I do the integration, I'll make sure that I actually flip those. And then that being the case, my boundary, which is how I caught that error, is again on this axis. So that is going from 1, and my dot is a little touch high, but 1 should be the high point. And then where is the lowest value where they're going to cross? Well, that's definitely below the negative 1. And although this looks like it's lower, it should be negative 2. Now to test that, I really should solve it algebraically to get that that is negative 2, because this is not done on graph paper. If it had been, I might be able to clearly see that if, you know, that spacing for negative 2 should be about here, which means that the 2 should be crossing around there. So my guess is it's my parabola that's a little too far out, something like that. Maybe it should have been a little tighter. And then I would see, oh yeah, it's crossing at the negative 2, so negative 2 is that other boundary. All right, so let's get back on to the integration here. So since the 3 minus y squared should have come first, this becomes 3y. Then this one is minus 1/3 y cubed. And now we're minusing this, so that would be minus y minus 1. So minus 1/2 y squared minus y. Now, putting those together, I was looking for their integration answer to make sure that I was on the right track. Okay, so here's their minus 1/3 y cubed minus the 1/2 y squared. And yes, when we put 3y minus y, we get plus 2y. So I'm going to cross these off so I know I have these three pieces. And we're plugging in our -2 and our 1. 1 being the highest, so that's going to keep -1/3 minus 1/2 plus 2. And then we're subtracting the lower -2 being plugged in. So that's -8, positive 8/3. -2, positive 4, back to -2, and then 2 with, so that's -4, so -6. Common denominator makes that a 3 and an 18. 8 minus 18, -10. So this part is now becoming positive 10/3, and here, again, common denominator of 6, so 2, 3, 12, -2, -5, 7, 6. That would need to make that 26. 7 minus 20, negative. Okay, now I'm looking for their answers to make sure we're on track. Okay, it is a denominator then of 6, which means it might reduce to what I need it to here. 6, 20, and that was minus, so no. Negative 13 over 6? Uh-oh, they don't have it as negative. Okay, let me pause it while I find where my math error is. Right in the very last step. This answer was 8 minus 18 was -10/3, minus the negative made that positive. There was my error. Then 7 plus 20 should be 27 over 6. And then that reduces down by 3 to 9/2 units squared. Oops. Okay. Now, is there an example 3? No, that was it.